There better be a good reason you're waking me up from my nap.
Sorry, Director, but we have sort of a problem.
What is it?
Well, something happened to the wiring in the nuclear reactor, and the power readings are not functioning. The on and off switch is stuck on, so we don't know what to do. We are unsure of the power that the reactor on campus is producing. There was a device used to use that measured the amount of blue light, which then determined how much power the device was using, but nobody in the nuclear department knows how to make it.
What would happen if we don't fix this?
If power levels reach a certain amount, all of beautiful NC State and its surrounding environment will turn into a second Chapel Hill. Chernobyl.
Well, that's not good.
Director, what should we do?
I know just the people to call. Hello? Get me the Soviets.
You should've never doubted me. I'ma work to my last breath. I'ma hustle to my last breath. Yeah, you should've never doubted me. The pain and the struggle followed me. My daddy never been that bothered me. And these cold streets made a man of me. Knew a time it'll come, they doubt me. Had to keep them OGs around me. Keep a young homie grounded.
You four are our only hope. You better have a plan. We have a plan. Do a PowerPoint presentation.
Our problem was we needed to measure the amount of radiation coming from the nuclear reactor here at NC State. To do this, we had to buy photodiodes and measure the difference in light coming from the reactor, since the amount of light and the amount of radiation have an almost linear relationship in the scale in which we were working. First, we brainstormed what we needed. We knew the probe needed to be clear on the tip, waterproof, and stable enough so the diodes didn't move once in the reactor pool. Silicone was definitely what we were going to use because we knew it was good at waterproofing. We then came up with multiple ideas of how to make the bottom clear. We also came up with ideas of how to stabilize the diodes, such as containers or friction. These ideas were our best option for creating the nuclear probe. For our approach, we needed to use a PVC pipe. The diodes were going to sit at the end, held in place by styrofoam with some sort of glass protecting them. We also needed to make sure the probe was waterproof. We would also put plexiglass on the end, attach it with glue, and then coat it in silicone to seal out water. In the building part, we first collected our supplies, including the PVC pipe and diodes. We then scavenged to find a clear PVC cap that gripped the end tightly. We decided not to individually stabilize the diodes since they couldn't move anyway once the end was sealed, and we wanted to keep our design simple and streamlined. We believed this helped our probe achieve relatively linear data readings on test day. Testing was the last step in the design process. Once we finished building the probe, we tested it in the nuclear reactor pool. The diodes were able to read through the clear end cap, and the silicone successfully waterproofed the probe. The testing went well, and now we have our results. Now on FED, we will use our results to predict within 2.5% of the actual level of radiation for the unknown reading.
Design challenges. Waterproofing was a major design challenge in this project. Our group came up with many good ideas on how to waterproof our nuclear probe. However, most of them seemed to overcomplicate it. To make our design as simple and as reliable as possible, we decided to go with a clear PVC end cap fitted with PVC cement and primer and a small bead of silicone around the top edge as an extra layer of protection. Mounting the photodiodes. We were originally going to keep the photodiodes held in place by a styrofoam cutout that each diode would slip into. However, the diodes ended up being shorter than originally expected. So, as a solution, we attached the photodiodes to one another in a linear pattern that stretched across the diameter of the PVC pipe. allowing them to fit snugly and not move after the end cap was attached.
At Freshman Engineering Design Day, also known as FED, we presented our research, design cycle, and data to the individuals that came to our booth. Our team finished 4th at FED, and our percent error ended up being 8.5%.
What we would have done differently. To improve the accuracy of our readings, we would have attached a more stable connection to the ends of our wires, such as alligator clips. The movement of the wires along the ends of the multimeter on test day caused the readings to jump up and down. If the ends could have been directly attached to the multimeter, then we could have gotten a more exact reading. Advice for next year's freshmen. Set up scheduled meeting times with your group. Make sure to let every group member voice their ideas because someone may have a really good one. Get started really early. Not being rushed allows for well thought out designs.
I stir the face, I stir the face. I stir the face, I stir the face. I stir the face, I stir the face. You a fucking bitch for the fame, won't you? You'll get up to a lane, won't you? Like an old school, I redid the frame on you. I got my old with me and they lay